Building services using SOAP. Wow, lots of you. Okay, so here's the problem, right? SOAP has a hard time scaling. And the reason that SOAP has a hard time scaling is over HTTP, SOAP uses the HTTP verb post. Post is a verb that's considered unsafe. That is, there is no prescribed effect of post when you do a post to a server. Therefore, responses to a post are not cacheable by anybody. Servers won't cache them, proxies won't cache them, intermediary caches, and clients won't cache them because they're not safe, right? There's no rules about what a post response should be and how it should be treated. And in fact, it's explicitly told not to ever cache it. Now, the reason that SOAP services have a hard time scaling because of that is because in order to scale, you really need to cache. Now, you can cache on the server side, right? You can do data caching, which is useful, right? Super useful. If you do sessionless kinds of SOAP services, you can scale out to a web farm. That's super useful. But this woman with the good questions about the cache control header, you said you were from MySpace? MySpace needs caching or else they're going to die, right? I mean, there's just no way. She's shaking her head yes. Thank you for validating my session. Without caching, MySpace, Facebook, Microsoft.com, big websites can't scale. Now, it may be that you don't need to scale to that level, but if you ever need to scale up above a certain level, at some point you're going to run into some very strong limitations when you're using SOAP-based services. So, why REST? Because REST-based services, read-only requests for read-only resources, can be done with a GET. GET responses can be cached. Okay? I'm going to run a little test here. I've got a ASP.NET web application with a WCF REST-based service. And what I'm doing is every time I refresh, it's going back. Notice the date timestamp changes from 52 to 55. So there's no caching going on. Every time the client makes a GET request, my server-side implementation is executing, generating the response, and sending it back. It's just simple XML. What I'm going to do here is I'm going to go back to my project, and what I've created here is I've created a VSTS, Visual Studio Team System test that does a load test. Okay? I'm going to go ahead and start running the load test, and while the load test is running, I'm going to explain to you what it does. It basically just tries to hammer that endpoint, that URI, as hard as it can for 60 seconds. Now, it's my laptop, right? It is dual core, and it's got 8 gigs of RAM. It's a good laptop. I'm not trying to show you actual real performance numbers. What I want to show you is the delta between no caching and caching. Right now, I'm not caching. It's gone for 36 seconds. And I've got 11, almost 12 requests a second. Total requests at this point is 351 requests. Okay? So 23 seconds remaining. I'm not going to get very much more. The idea is this is the maximum I can get with this particular setup in a real test that you're looking for real performance numbers, right? You'd never do it on the same machine, right? And you wouldn't use laptops. You'd use real machines, et cetera, et cetera. But what I want to look at is the delta of what I get. So 2, 1, 0. OK, I got up to 711 requests in 60 seconds, almost 12 requests a second. I'm going to go, that's just an error that I don't have a database. I'm going to go over to IIS. I'm going to go down to the output caching node in the IIS config, and I'm going to add a .svc extension. I'm going to turn on kernel mode caching for 30 seconds. Okay? So just go in and highlight this for a second. Now, actually, let me go just make sure this works, and we'll come back to that in a second, because I can blab about that while this test is going on. Okay, so notice it says 141.05. It's caching, right? The server is caching the response for me. I'm going to go back and run the test again. Okay. Now, the thing I was going to say is, what I'm showing you is one kind of caching. This is server caching using IIS. IIS has 2 modes of server caching. It caches at the user mode level and the kernel mode level. Obviously, kernel mode is better. It means that the actual response of my page, not my page, but my service, is stored in the kernel. And because HTTP requests now come in the kernel since 2003, it's just a very quick return back to the client. You can't cache everything in kernel mode because if it varies per user or per query string or per header, then you have to go to user mode caching. This is just one form of caching, right? But what I want to show you is what's the difference in terms of performance on this particular machine. There's 23 seconds left. I'm already up to 43,000 requests in that 40 seconds. How many did I get the first time? 711. Big difference, small difference. How many people think big difference? Yes, big difference. So this is what when I say you can't. It's hard to scale without using REST. It's mostly because in REST we can define those operations that are just to get data as get, which is what they really should be. We can give that data back, which means everybody can cache. Everybody who wants to cache and can cache based upon our headers, we'll talk about some of the cache headers a little bit, will be able to cache this data. And that's going to increase our performance. That's going to mean that we're going to be able to scale. Now, of course, not every system can have this kind of caching, right? Obviously, if we had a website that was returning real-time stock data, we wouldn't turn on kernel mode caching for 30 seconds because, of course, that 30 seconds could mean millions or billions of dollars. I guess now hundreds of thousands of dollars, right, based on where the Dow is right now. But we probably wouldn't build that system with HTTP and REST anyway. We probably use some sort of really low-level socket or messaging mechanism that's super fast, right? But for most systems, building services using REST can really, really help you scale, right? This is the big thing. Okay. So what else am I going to show you? What else I'm going to show you is I'm going to go back to my conditional get example, and most of you were in the room when I did this. This is actually also a regular service. Now, this is one of the things in WCF that actually is kind of a limitation of WCF. It's hard in WCF today to be able to create one service that just serves up JSON for AJAX and XML at the same time. It's possible, but it's not simple or easy. I'm going to show you something from a thing that's called the REST Starter Kit. The REST Starter Kit is a bunch of bits that the WCF team has put out on Codeplex to sort of highlight where they're going with REST support in the next version. And it's all up there with all the code and everything. And one of the things that they've done is they've made that a lot easier. But right now, in this version, unfortunately, I basically have one implementation that's a JSON implementation and one implementation that's an XML implementation. But basically, what I've got here is I've got a service that returns data. And I think we added a couple pieces of data in the last talk. So let me go ahead and go view in browser on mixservice.svc, not the JSON version. Let's see, what browser did that come up in? This one. OK? So we've got a couple of things about Mix, right? Somebody said that they really like that it's in Vegas. Somebody said that they really like that it had good ice cream. So we've got a couple of things that we've put in here. Now, if I go to mixservice/6, which is the URI for that particular resource, so this is how we build RESTful services. I need to make the browser bigger so you can actually see that URL. Is we, instead of having verbs like get order and get customer, we have URIs that represent resources. Now, eventually, those are going to get routed to some methods that we write that are called get customer or get orders. But on the outside, it's just a set of URIs and resources that are returned based upon certain requests to those URIs. So one of the things you can do at an individual resource level, and sometimes in collections of resources, as I'll show you, is you can do and implement what's called conditional get. Okay? Here's how conditional get works. It's actually fairly easy. In conditional get, what the server does is it returns some information to the browser. I shouldn't say browser. In this case, the browser, because I'm using the browser. User agent, right, because it can be programmable user agents as well. So the server returns some information to the user agent about the state of the resource, right? Like when was it created, or an opaque identifier called an e-tag, which is the version of the conditional get implementation that I prefer the most. It returns this to the user agent, and if the user agent wants that particular resource again, the user agent, when it makes that GET request, passes that information about the resource back as a header, and it basically says, hey, we want this resource again, but if it hasn't changed since the last time we got it, don't bother to send it again. Just tell me that it's the same. That's conditional GET, right? The user agent does a GET request. It includes extra information in the headers that tells the server, I want this resource, but only if it's been modified since this particular time or this particular version. And then the server says 304. 304 is not modified, right? It sends back a response that says, hey, it's the same. If you use like Fiddler, and again, if you go to sites like Twitter, I promised I wouldn't demo a Twitter client, but I didn't promise I wouldn't mention it. MySpace, any big websites, and if you watch, your browser is doing this, right? Your user agent, even when you press F5, most of the time is going to be just getting back a 304 and just showing you the same page. And this is another way that you can scale services a lot. And with WCF, it's fairly easy to make this work, okay? I've got some code here. I'm going to create a method called, this doesn't need to be public, static get e-tag, and I'm going to pass in a thing about mix. Okay? So I'm going to do the version, actually I don't want them to be static, it's just string. Okay. I'm going to do the version of conditional get that gets back this opaque identifier. And generally speaking, what you do is you take some data from your resource, you hash it, you get the bytes, and then you make an MD5 hash of it, and then you return that as a particular HTTP header in the response that you send back to the client. It's called e-tag, interestingly enough. So I'm going to provide that implementation, which is here somewhere on my... there it is. I actually had it all implemented. Sorry. Get e-tag. Okay. So how do you do this? Well, it's really useful if your resource has a last updated timestamp. This is a pretty canonical implementation where I'm taking the identifier of the resource, combining it with the last time it was updated, getting the bytes of that, hashing that, and returning that basically as the e-tag value. Okay? And if my resource doesn't change, that e-tag is going to continue to stay the same, and stay the same, and stay the same. Okay? I need to change my implementation a little bit. Inside of my implementation, okay, I'll just delete the old implementation. What I'm going to do is just put in a little bit of code. And the code basically generates the e-tag. It looks to see if the if-none-match header has been passed in by the user agent. If that has been and it matches, I'm going to return status code not modified, which is 304. I'm also going to say suppress entity body equals to true, right? These two things are going to save a lot of server-side processing, right? WCF won't have to serialize my response. The server doesn't have to send back the response. All that gets sent back is the headers. The client doesn't have to parse the response. And bandwidth saving as well, right? The bandwidth on the network has been saved because the resource didn't come back. It's just a blank thing, okay? So let me go ahead and build this. Let's go back to Fiddler. I'm going to go in Fiddler and ask for, whoops, home end, ask for resource 6, okay? So that gives me a 200. If I look at the raw response, notice it returns the actual resource, a 200 OK, and then there's my e-tag, right? So the e-tag is this coded string that's the hash of the information. Now, if I'm a bad client, of course, I can subvert this, because if I go back and do a GET request again, notice, again, I get a 200, right? It's up to the client to take this e-tag in their request to say if none match. Okay? So when I do that and I do if none match, now I get the 304 not modified, right? And so this is the response that I'm looking for, right? This is what I want in response to a request from a user agent who's asking for a resource using get that hasn't changed. Because, you know, if somebody's pressing refresh or clicking buttons in their UI or refreshing their browser and something hasn't changed in the back end, right, you don't want the whole thing to have to happen over and over and over again. I could go into the database. If I go into the database, you know, and if I change the, let me change this one. I don't know. Okay. Change that to a different date timestamp. Now if I go back to Fiddler and go to Request Builder, and let's clear all those out so we know exactly what we're doing here. Oh, I changed the wrong one. Thank you. Well, I was like, oh no. There we go. Okay? So 200, and it's got a new E tag, right? Because that value changed, right? The last modified timestamp changed. Okay? Make sense? So caching can really only happen when you're doing HTTP GET requests. Can't happen with SOAP, at least not in the terms that I'm showing you now. Built into HTTP is this other way of caching called conditional GET that really, I mean, you can't really underestimate the amount that this adds to, you know, the web really wouldn't be the web if they didn't have GET, if they didn't have conditional GET. The web, because the web would just be too slow. Even with, you know, a broadband, sites would have a hard time scaling up to the capacity necessary to handle the traffic. I mean, look at Twitter, right? It crashes like, what, 20 times a day, right? And they're still doing this. And so it's hard to get to that scale. And there's no reason why you can't take advantage of that at a smaller scale, right? I know all of you are not writing Twitter or MySpace. I always say you guys aren't writing Twitter or MySpace. We actually have somebody from MySpace here. So that's the deal there. OK, so I'm going to show you one more thing. I'm going to show you this solution already filled out. And what I've done is I've actually added conditional GET to the top-level resource. So what I'm doing is I'm saying, OK, what represents for the collection of things in my collection, my top-level resource, what represents something that's changed? And so basically I'm just running a little bit of link, you know, linked entity framework here, and I'm saying, you know, give me the resource that has the most recent last updated time, and I'm going to use that to build the E tag, and then, you know, again, I can cache that top-level resource, so all the list of all my things. Now, I mentioned the REST Starter Kit. This is something that if you're doing stuff with REST, you definitely want to download and take a look at. What I've built here is I've built a WPF application. So let me go make sure that this works. Okay. The WPF application, I've built it using the new HTTP client that's in the REST Starter Kit. And the cool thing here is what I'm going to do is I'm going to make the initial GET request to get the data. And then I'm going to create this thing called a polling agent. Okay? I'm going to post this code up on my blog, so you guys can download it later if you want to see it. The polling agent is part of this REST Starter Kit. What the polling agent does is basically you feed it a URL, and the E tag, or the last modified, which is the other way to do conditional GET, and it goes back and polls in the background looking for an update, right? It does the thing that I just did, right? It sends a GET request for the same URL with the E tag as the if value of the if none match header, and when the service returns 200 instead of 304, it calls my callback, right? So all I do in the callback is when the resource changed, all I'm going to do is basically, you know, update my UI. So let's run this and see if this works. I'll do a Control F5, run this WPF application. Maybe I won't. How about we do a debug, start new instance. All right. So, you know, there's my thing, right? There's my resource. Let me go ahead and add a new resource. Because if I add a new resource, right, this is going to be mix service.svc. This is in the browser, right? So this is in the browser. If I want to add a new resource, what I'm going to do is I'm going to do a post to that particular URI. Okay. Let's make this a post. I don't want the E tag, but what I do want to do is I want to specify what my content type is. This is application/XML in this case. And I'll put in a request body. I'll do a little copy and paste to save some time here. Thing about Mix. Where's the end? There it is. All right. So go back over and set the request body. Conditional get rocks. Not my talk, just in general. Last updated, well, I'm not going to really set that, right, because the server's going to set that. I'm also not going to set the ID. So what I'm going to send in is just, the representation of the resource as the client knows about it. I'm going to do a post to that URI. I'm going to press an execute. I get back a 200 OK. That, of course, added a new resource. If I go back and look at this in the browser, I should get 3 instead of 2. I do. And if I go back and look at my application, there we go. Right? Without doing anything in my application, again, part of this starter kit is this nice implementation of conditional get, which is basically that's what you want, right? In your application, what you want is you want to say, okay, let me give this resource. I really need to know if that resource is updated. So basically, that's polling. That's just the way HTTP works, right? There's some ways to hack callbacks in, but the standard HTTP cross-technology way to do that kind of implementation is to poll. And so this implementation just polls, and by passing it and using conditional get, you're not having to refresh every time, and you're yourself check to see if the resource has changed. The server can check for you and tell you. And as soon as the server says 200 OK to a GET request that the polling agent has done, it fires the delegate, fires into my code, and I get that data. OK? So I think I went over, but are there any questions? Question?
Using Ajax, whether it's the Microsoft Ajax framework or jQuery, XML, HTTP, do they automatically do conditional get? And if not, what does it take to get it?
Do they all do conditional get? Not to my knowledge. I don't think that they all do. I can't remember off the top of my head which do. It doesn't take a whole lot because you can set the headers and you can get the E tag, so it's not a lot of work. There's a question here. Yes. Do they have something like that in Silverlight? They will eventually have all of this stuff in Silverlight, but right now they don't, no. What they do have in Silverlight is they actually do have a callback mechanism. I said a few minutes ago, the HTTP implementation agnostic way to implement what I just did is to do polling. Because Silverlight has a WCF stack built in, they actually have a binding that will do duplex communication. So right now in Silverlight, you could just do it with a duplex, right? And have basically the Silverlight app would be waiting, right? And waiting for the server to call it back. Question here? Oh, you mean with REST? Oh. Oh, yeah. Oh. Yeah, as far as I know, it uses standard port 80. Oh, sure. Let me show that one more time. In IIS, all I did was I went to the IIS manager for my particular web application. There is a output caching, thing here, right? So you just say output caching. Of course, you could do it in the XML as well. It's just a application.config file. And then I said add, right? I said add a new cache rule. I just put in .svc. You, of course, could put in this service.svc, right? And you can put in wildcards as well. And then you pick what kind of caching you want. Again, kernel mode caching really only works if you have one resource for everybody, and it doesn't change based upon any sort of inputs. The user mode caching can change based upon query strings, right? And then, of course, this is server-side caching, right? So this is client will make a request. Every time the client makes a request, it gets back a resource, but it's cached somewhere high in the service level, so your code doesn't have to execute again. Versus conditional get, which is a whole other sort of form of caching, right? Client-side caching. Okay. Is there another talk in this room right now? Nobody's knocking me off, are they? I will stay around and answer questions for a couple minutes until they kick me out of here. It looks like not till 12:55, so I've got a few minutes to answer questions. First come, first serve. I got 5 copies of RESTful.net. Oh, wow. Jeez. Okay.